There are 10 temperature levels in this universe. You exist at exactly one of them. At level 1, atoms freeze so completely that quantum physics breaks. At level 10, the temperature is so high that physics itself ceases to exist as we know it, and it only lasted 10 seconds at the very beginning of everything. Here is what life looks like at every single level between those two ends. Level 1, the year is 2021. In a laboratory at the University of Bremen, Germany, a magnetic trap holds a cloud of rubidium atoms at 38 picokelvin, 38 trillionths of a degree above absolute zero. The atoms stop behaving like particles and merge into a single quantum entity called a Bose-Einstein condensate. Nothing in the natural universe is this cold. That cloud of rubidium is the coldest known point in the entire observable universe. But the strangest part is not what happens when matter gets that cold. It is what happens to a creature barely half a millimeter long that survives temperatures almost as extreme, in the opposite direction, and somehow keeps walking. Level 2 sits at roughly 272 Kelvin, just below the freezing point of water. This is the temperature of a cryptobiotic tardigrade, a water bear locked inside a dried-out husk of its own body. Scientists at Hokkaido University in 2016 revived tardigrades frozen for 30 years in Antarctic ice. They walked again within hours of thawing. The tardigrade performs this miracle through a process called cryptobiosis. It expels nearly all water from its cells, replaces it with a glass-like sugar called trehalose, and essentially turns itself into a biological fossil. Its metabolism drops to 0.01% of normal. It is alive and not alive simultaneously, a paradox wearing 8 stubby legs. Level 3 rises to 310 Kelvin, 37 degrees Celsius, the interior temperature of a living human body. The human heart beats approximately 100,000 times per day. At this exact temperature, hemoglobin binds oxygen with optimal efficiency. Enzymes fold into precise three-dimensional shapes that would collapse just 10 degrees warmer. Human existence is a narrow thermal knife's edge. Consider what that means. The human body tolerates only about 4 degrees of core temperature rise before seizures begin. A fever of 41.5 Celsius, 314.5 Kelvin, can cause permanent brain damage. The tardigrade endures thousands of Kelvin of temperature swing. The most sophisticated organism on the planet survives a thermal window barely wider than a warm bathtub. Level 4 reaches 600 Kelvin, roughly 327 degrees Celsius, the temperature found inside active hydrothermal vent systems along the mid-Atlantic ridge. Here, Rimicaris exoculata, the eyeless shrimp, crowds in dense mats around chimneys that pulse with superheated brine. Up to 2,000 of these shrimp pack into a single square meter of vent wall. This is extremophile life at visible scale. What makes these shrimp extraordinary is a photoreceptor organ on their backs that detects faint infrared glow from the vent fluid itself, navigating by heat the way surface animals navigate by light. But the truly disorienting fact is still ahead, because the temperature at the next level is not measured in hundreds. It is measured in millions. What happens at scene 15 is what this video was built for. Level 5 crosses into 10,000 Kelvin, the surface temperature of the hottest category of main sequence stars, the O-type blue giants. No biological life exists here. This is the realm of pure plasma where electrons are stripped completely from their nuclei, but pause on that number, 10,000 Kelvin. The tardigrade has already survived temperatures approaching 420 Kelvin. Its ceiling is real and close. The gap ahead is almost incomprehensible. The transition from level 4 to level 5 is not a gradual slope. It is a cliff. Between the shrimp's vent at 600 Kelvin and the stellar surface at 10,000 Kelvin lies a zone where every known biochemical bond breaks, every protein denatures, every cell membrane dissolves into raw atomic constituents. Life does not degrade here. It simply ceases to be a category that applies. Pattern interrupt. Stop. Consider this single number, 5,778 Kelvin. That is the surface temperature of our own sun, and it falls between level 4 and level 5 on this scale. The hydrothermal shrimp lives at 600 Kelvin. The sun's surface is nearly 10 times hotter. The sun's core runs at 15 million Kelvin. These two facts cannot comfortably exist in the same sentence, and yet here they are. Level 5 in full. Rigel, the blue supergiant in the constellation Orion, burns at 12,100 Kelvin across a surface 78 times the width of the sun. Rigel produces 120,000 times the sun's luminosity. If placed at the center of the solar system, it would extend beyond the orbit of Mercury. At this temperature, hydrogen atoms exist only as bare protons drifting through a sea of freed electrons. Level 6 approaches 1 million Kelvin, the temperature of the Sun's corona, the thin outer atmosphere extending millions of kilometers into space. Why the corona is hotter than the surface below it remains one of astrophysics' deepest unsolved problems. In 2021, NASA's Parker Solar Probe flew through the corona at 532,000 kilometers per hour and survived using a carbon composite heat shield 11.4 centimeters thick. Level 7 reaches 100 million Kelvin, the ignition threshold for helium fusion in the core of aging giant stars. At this temperature, helium nuclei overcome electromagnetic repulsion and fuse into carbon in an explosive event called the helium flash. In a star like our Sun, this flash will release as much energy in a few seconds as the Sun currently emits across 100,000 years. But first, understand what the tardigrade can actually survive. Here is the tardigrade's true upper limit, confirmed in laboratory experiments published in 2020 by researchers at the University of Copenhagen. At 420 Kelvin, roughly 147 degrees Celsius, sustained for 24 hours, half of all tested tardigrades die. The thermal ceiling of the most resilient animal on Earth is 420 Kelvin. The helium flash runs at 100 million Kelvin. The distance between those two numbers is the distance between a candle flame and the universe itself. Level 8 enters the domain of gamma-ray bursts, the most energetic explosions in the known universe since the Big Bang. When a Wolf-Rayet star collapses, a jet of radiation and plasma erupts at near-light speed. Temperatures at the central engine reach 10 billion Kelvin. GRB 80319b, detected on March 19, 2008, was briefly visible to the naked eye from Earth despite occurring 7.5 billion light-years away. Level 9 is where the numbers stop making visceral sense. The temperature inside a collapsing stellar core during a supernova approaches 100 billion Kelvin. Neutrinos, particles that normally pass through a light-year of lead without interaction, become trapped by the sheer density of matter at this temperature. The tardigrade survives at 420 Kelvin. This is 100 billion. That ratio deserves a moment of silence. But first, the viewer needs to understand what actually exists at the boundary of temperature itself, and what was there before anything else existed. Before level 10, there is a wall. Physicists call it the Planck temperature, 1.417 times 10 to the power of 32 Kelvin. Written out, that number has 32 zeros. Every temperature encountered so far in this video, the Brayman-rubidium cloud, the tardigrade's icy death sleep, the helium flash, the gamma-ray burst, all of them together do not account for a single rounding error at the base of that number. The Planck temperature is not an arbitrary limit. It is the point at which the wavelength of a thermal photon becomes smaller than the Planck length, 1.616 times 10 to the negative 35 meters, the smallest meaningful distance in physics. Below that scale, quantum mechanics and general relativity both fail to produce valid predictions. The mathematics does not diverge. It simply stops. There is no equation that survives level 10 intact. What existed at the Planck temperature was not stars, not plasma, not atoms, not quarks. Current physics cannot name what it was. The four fundamental forces, gravity, electromagnetism, the strong force, the weak force, had not yet separated into distinct interactions. They existed as a single unified force whose nature remains entirely unknown. Every particle accelerator ever built reaches temperatures billions of times colder than this wall. The Large Hadron Collider at CERN produces collision temperatures near 5 trillion Kelvin, hotter than level 8, hotter than most supernovae, the hottest manufactured temperatures in human history. The Planck temperature is still 27 orders of magnitude beyond that. The LHC, the greatest machine humans have ever constructed, reaches roughly 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 tardigrade. It is the protagonist of this story for a reason. Ramezadius variornatus, the species studied at the University of Tokyo in 2016, carries a unique protein called DSUP, damage suppressor, that physically wraps around its DNA like a shield blocking radiation damage. It survives hard vacuum. It survives pressures of 600 megapascals. It survives doses of radiation 1,000 times lethal to humans. And it still cannot survive 421 Kelvin for a full day. That is the revelation the tardigrade carries. Not that life is fragile, but that even the most thermally resilient multicellular life on Earth occupies a range so vanishingly small on the cosmic temperature scale that it cannot be drawn to scale on any printed diagram. If the full temperature range of the universe were represented as the distance from New York to Los Angeles, the tardigrade's survivable range would be less than the width of a single atom. What happens in the next two scenes reframes everything. So here is what the temperature scale actually looks like, assembled in full. Level 1, 38 picokelvin, the Brayman rubidium cloud. Level 2, 272 Kelvin, the frozen tardigrade. Level 3, 310 Kelvin, the human body. Level 4, 600 Kelvin, the vent shrimp. Level 5, 12,100 Kelvin, Rigel's surface. Level 6, 1 million Kelvin, the solar corona. Level 7, 100 million Kelvin, the helium flash. Level 8, 10 billion Kelvin, a gamma-ray burst. Level 9, 100 billion Kelvin, a collapsing stellar core. Level 10, 1.417 times 10 to the 32 Kelvin, the Planck wall. The distance between level 1 and level 2 is almost nothing. The distance between level 2 and level 10 is everything. All of chemistry, all of biology, all of human civilization, all known life in the universe clusters inside a region so close to absolute zero that, on a logarithmic scale, the tardigrade and the Brayman lab are nearly neighbors, pressed together against the cold end of a scale that stretches to infinity. There is no level 11. Physics does not permit a temperature beyond the Planck temperature in any currently understood framework. It is not that the universe becomes more extreme beyond that point. It is that the concept of temperature, which requires distinguishable particles exchanging distinguishable quanta of energy, may not apply to whatever existed before the Planck epoch ended at 10.3 seconds. The word temperature loses its definition. At 10.3 seconds after the Big Bang, 1 Planck time unit after the origin of everything, the universe cools below the Planck temperature, and physics, in the forms currently understood, switches on. In the 13.8 billion years since that moment, matter condenses, stars ignite, planets form, oceans appear, and eventually a half-millimeter creature with 8 legs evolves in a puddle of Antarctic moss, stuffs its cells full of trehalose sugar, and waits out conditions that would incinerate most life on Earth. The tardigrade does not know it lives near absolute zero on a cosmic scale. It does not know about the Planck wall. It does not know that its entire survivable thermal range, from minus 272 Celsius to plus 150 Celsius, represents approximately 422 Kelvin of tolerance out of a universe that spans 1.417 times 10 to the 32 Kelvin. It simply survives. It has been surviving, largely unchanged, for 530 million years. It survived the asteroid impact. It survived the Permian extinction. It is surviving right now in Antarctic moss in a state that is neither fully alive nor fully dead. And now the loop closes. The most thermally resilient animal on Earth, Zodius variornatus, the tardigrade, survives a thermal range of 422 Kelvin. The temperature that ended at 10.3 seconds into the universe's existence was 1.417 times 10 to the 32 Kelvin. The tardigrade cannot reach it. Nothing alive can reach it. Nothing built can reach it. And it only ever existed once. The question worth leaving in the comments: if that temperature existed again, even for 1 Planck instant, what would happen to everything else on this scale?